Good morning, y'all. So I wanted to continue our lessons with simplifying radicals. The other day we talked about just simplifying a square root when it has just a number on the inside, and then if it has a coefficient on the outside, you multiply whatever you're bringing out with that coefficient. Now today I wanted to expand a little bit more and what happens if we have variables inside of our radical. Now, this note template, for those of you that I saw in class, you should have this already for your notes. For those of you that I missed in class because we weren't in school, I left the template in the topics board, so you can download that to your iPad and you can work through this with me if you'd like. So go to the topics board to find that note template. So what if we have variables inside of our radical? Well, it's pretty simple. You will get the hang of it very quickly here. If there are even exponents, what we're going to do is we are just going to divide by 2. Missed an E there. We're going to divide by 2, and I'll show you what that looks like. If we had odd exponents, what we're going to do is we're going to rewrite it so that way it's a combination of an odd and an even. So as an example, if I had like x to the third, I would rewrite that as x squared times x to the first. And I'm always going to do with that number, so like let's say I have a to the 7th. I always want to rewrite it as the even number that's one less than it, so a to the 6th times a to the 1st. And I'll kind of show you why as we work through examples here. So why are we just dividing it by 2? Now with the square roots, and we talked about this a little bit, the number that we don't see, the index here, is always 2. So that index is actually telling us how many times that we are separating out our variable here. So the question that I always ask myself is how many times does the index go into the actual exponent itself? So how many times does 2 go into 2? Well, it's 1. So the square root of x squared is just x to the first, or just x. Similarly, if I have x to the 5th, now let's rewrite this as x to the 4th times x to the 1st. Because the index here of 2, how many times does 2 go into 4? Well, it goes in twice, so that means that x squared comes out. And then 2 here doesn't really go into 1, so we're going to leave that inside. Now, instead of rewriting, you could always ask yourself, hey, how many times does 2 go into 5? Oh, it goes in twice with only 1 remaining here. So that's another way to think about this. And that kind of helps once you get to problems where you're dealing with more variables. So here we have 2 different variables. The index here is 2. I'm going to ask myself, and I'll use different colors, how many times does 2 go into 3? Well, it goes in once, so that's x to the 1st that comes out. And 1x would be left inside there. And then for the y's, how many times does 2 go into 2? Well, it goes in once with no remaining. So my answer would be xy times the square root of x. And here's a larger problem next to it. X to the 7th, y to the 12th, z to the 13th. This one's pretty fun because you got a bunch of different ones here. So how many times does 2 go into 7? It goes into it 3 times. So x to the 3rd comes out. And there's going to be 1 that remains on the inside. How many times does 2 go into 12? That goes in 6 times. So y to the 6 comes out with no y's remaining. And then how many times does 2 go into 13? It goes into it 6 times. So z to the 6 comes out. And there would be 1 remaining here. So my answer, x to the 3rd, y to the 6th, z to the 6th times the square root of xz. I have a few more examples here just in the notes. I didn't make these available for you, so maybe you just kind of want to watch, and you can take notes separately if you really want to. In these, I included numbers with the coefficients on the inside, so practicing that concept of simplifying a square root with a number and simplifying it with a variable as well. So I've showed a couple different ways. The factor tree is the one that I like the most here. So if I'm trying to simplify 112, let's say I divided that by 4, I'd get 28. And then 4 simplifies to 2 and 2. And then 28, I have 4 and 7. And then 4, 2, and 2. So there's my pairs here. I've got a pair of 2's with another pair of 2's. Both of those numbers are going to come outside. So 2 comes out with another 2 that comes out. And then this 7 kind of stays inside of our square root. So let's rewrite that here. 7 remains. And then I do want to do this variable as well. So we ask ourselves, how many times does 2 go into 5? It goes into it twice. So that means n squared comes out and 1n remains. So if I'm going to simplify all of this, it's 4n squared square root 7n. There's always a bunch of different ways. This is kind of doing it all in one step. I have had students in the past that always break this apart. So they say, okay, it's the square root of 50, and then it's the square root of a to the 7th, and then they just combine their answer at the end, which is perfectly fine. So 50, we'd have 2 and 25, and then 25 is 5 and 5. So I have that 5 that comes out, and then the square root of 2. That 2 didn't have a buddy, so it remains inside. And then for a to the 7th, my index here is 2. How many times does 2 go into 7? It goes in 3 times, so a to the 3rd comes out, and 1a remains. Now, how would I combine these two here is that my numbers on the outside are going to stay on the outside. So I have 5a to the 3rd. And then inside of my square root would just be the combination of what I have left over, this 2 and this a, so 2a as my final answer. Let's keep this going here. Now I'm going to throw in a couple different variables. So again, if you like the separated apart method, you can certainly do so. So let's do that. Square root of 72, square root of u to the 4th, square root of v to the 7th. The square root of 72, let's say I broke that apart by 8, we'll say. So I have 8 and 9, and then 8 is 4 and 2, and 4 is 2 and 2, and then 9 is 3 and 3. So I've got my pair of 3's here with my pair of 2's, and there's a leftover 2. So that means outside I have 3 times 2 square root of 2. So that simplifies to 6 square root of 2. For the u's here, the u to the 4th, how many times does 2 go into 4? It goes in twice with no remainder. So that's u squared with nothing inside. And then for the v, because the index is 2, how many times does 2 go into 7? It goes in 3 times. So that's v to the 3rd and remainder of 1. Now, combining all 3 of these, the numbers on the outside stay on the outside, so that's 6u squared v to the 3rd, and the remainder on the inside here, square root 2v. Here is my answer. A few more problems to go through here. 40a to the 7th, b to the 3rd. So let's break this apart again. So square root of 40, square root of a to the 7th, square root of b to the 3rd. So for 40, I would have 4 and 10. 4 is 2 and 2. 10 is 2 and 5. So I really didn't need to split 10 because it's not going anywhere for me. Because all I have is a pair of 2s with a leftover 2 and 5. So that means a 2 comes out, and then 2 and 5 remain on the inside. So it would be 2 square root of 10. For my square root of a to the 7th here, 2 goes into 7 3 times, so a to the 3rd with a remainder of 1. And then the square root of b to the 3rd, 2 goes into 3 1 time, so b to the 1st comes out with a square root of b left over. Let's combine all this for our final answer. It's 2a to the 3rd, b square root, everything left inside still, 10a b. And then 2 more problems here. Pick bigger numbers, and I picked 3 different variables just for fun. So square root of 150, square root of x to the 4th, square root of y squared, and square root of z to the 7th. So 150, I could do 25 and 6, and then 25 is 5 and 5. 6 would be 2 and 3. So my pairs here, I have a pair of 5s, left over 2, left over 3. So 5 comes out, 2 and 3 both remain on the inside, so that gives me 5 square root of 6. For the x to the 4th, how many times does 2 go into 4? It goes in twice, so that means x squared comes out with no remaining. For the square root of y squared, 2 goes into 2 1 time, so that's just y. And then for square root of z to the 7th, 2 goes into 7 3 times, so z to the 3rd comes out with a square root of z remaining. Let's put our answer together. All of the things on the outside, 5x squared y z to the 3rd with the square root of 6z remaining on the inside. And then one final problem here, 175 xy to the 3rd z to the 4th. Again, let's split this apart. Square root of 175, square root of x, square root of y to the 3rd, and square root of z to the 4th. 75, I'm going to do is 25 and 7, and then 25 is 5 and 5. So there's my pairs there with this remaining. So 5 square root of 7. For the x, how many times does 2 go into 1? It doesn't, so this is going to remain the square root of x. It can't simplify anymore. For the y, my index of 2, how many times does 2 go into 3? It goes in once, so y comes out with y remaining. And then for the square root of z to the 4th, that would be z squared with no remaining. So my final answer, I have 5y z to the 2nd on the outside, and then the square root of 7x y remains. So that's what I have for you today. I want you to practice on that in-class worksheet of simplifying radicals with variables on the inside. Make sure that you join my Zoom conference today. During the allotted time, I emailed you the link to join my Zoom as well as the password to do so. So join at the appropriate time because otherwise I won't be in there. So you can ask questions. Today may be more of like explaining how to work on things, and then you guys work on it after the conference, and then we set up another time so that way we can chat. As always, make sure you like and subscribe to my YouTube channel here as I post more and more videos as we are not in school, and then feel free to reach out with any questions.